Which property? Associative, yes. Associative says I can group different numbers together, and commutative says I can do what to them? I can move, they can what? They can commute, they can move different places, right? It doesn't change it. So we're going to use both of those properties to be able to work this problem. So because of those, let's group together our two factors, which are 3.5 and what? And 1, right? Then let's group together our powers of 10, which are 10 to the 6th and 10 to the 9th. Now I can work this problem and keep it in scientific notation, because what's 3.5 times 1? Then I have times 10 to the what power? What do we do when we're multiplying? We do what to our exponents? When we're multiplying, we add our exponents. Good. So I'm going to add 6 plus 9, and I get 15. So what is this number representing, though? It represents what? The total number of ants, right? So I would say there's 3.5 times, or 3 5/10 times 10 to the 15th power ants in the Amazon rainforest. Okay? Yep, that would be a lot of ants. All right. Now let's do number 2. I'm going to set it up and then y'all are going to work it. So it says a dime is what? 1 35/100 times 10 to the what power? -3 meters thick. It says, what would the height of a stack of 1 million dimes be in scientific notation? So we have one dime, and it tells us how thick it is. We're trying to figure out how high that stack would be with 1 million dimes. So we need to do what to these two numbers? Multiply, right? Well, how would I write 1 million in scientific notation? 1 times 10 to the 6th power. Good. So what do I need to do here? I need to group together what? My factors and the what?
Like I know what it is, but I can't.
Powers of 10. All right, y'all work that out. All right, y'all help me out. So we group together our factors and we group together our powers of 10, right? Now we can work it out. So what's 1 35/100 times 1? Good, just gives us that same number because anything times 1 is itself. Well, now we have times, and we keep our base, which is 10, right? Now, what do we do to our exponents when we're multiplying? We add our exponents, right? So if we add our exponents, we're adding a -3 plus 6. What are we going to get there? +3, right? Be careful with your integers and make sure, if I'm on a number line and I'm at -3 and I'm adding 6, well, I'm going to the right 6, right? Because I'm adding. So make sure that you don't accidentally say that you just do 6 minus 3 or end up with a -3. Okay? Remember, we subtract because they're different signs, and we keep the sign of a larger number. So it's got to be positive, especially if you think about it on a number line. I'm at -3. I need to go to the right 6. I end up at a +3. Okay? Good. All right, now we're going to do dividing. Okay? One thing I want y'all doing, especially in the next couple of days when we start doing these, is as soon as you look at a problem, I want you to write out to the side what you're doing, because we're having multiplying, we're having dividing, and tomorrow we're going to add in adding and subtracting. So I want you to make sure you don't make careless errors. So as soon as I look at the problem, I'm going to write out to the side, and you can abbreviate. I'm going to put dividing / what do we do to our exponents? Subtract our exponents. Okay, so I'm just going to abbreviate, but I want y'all to start doing this as soon as you look at a problem, because on your homework tomorrow, you're going to have a lot where you're doing multiplying one problem, dividing one problem, and then subtracting the next, and it's a bunch of different rules and things. So let's make sure that we don't make careless errors. Okay. All right. So we're dividing here. Well, we're going to use the same property, associative property, and be able to group our factors together. And then what do y'all think? Group our what together? Powers of 10. Good. So if I group my factors together, I'm I'm going to group my factors together. Then I'm going to multiply it by dividing my powers together, right? So I'm representing the same exact problem. I'm just grouping it together since we're multiplying on the top and the bottom. Okay? All right, so we've got to what? Divide 7 and 56 by what? 3 and 15 hundredths, right? So our first step is we got to move our decimal, right? We got to move it what? 2 places? And then we've also got to move this decimal what? 2 places. So I'm going to go ahead and bring that decimal up right here so I don't forget about it. Okay? All right, so somebody tell me how many times 315 will go into a 756? 2. Good. So what is 315 times 2?
625.
Close.
630.
630. Good. So what is 756 minus 630? 126. Good. So we get 126, and then we're going to bring down our what? Our 0, right? So what do y'all think? How many times will 315 go to the...
4.
Good. 4. We'll go into it evenly?
I don't know. Yes. Yes. I don't know.
Yes. So 4 times 315 gives you what? 1,260. So we're done. So what do we get as our factor here? 2.4?
10 to the 5th power.
And then we're dividing, so we subtract our exponents and we get 10 to the 5th power. Good. And that is our answer. That's a lot less work. You're just dividing their factors here, whereas if you would have had to put these numbers in standard form and then divide them, you would have had a lot more numbers to deal with. Okay. Does everybody have this? Okay. All right, y'all are going to do this one on your own. So we got to group the factors together, and then we group our powers of 10, right? So we know it's going to be these two numbers divided times 10 to the what power? Because we do what to our exponents? We subtract our exponents, so we get 10 to the 2nd power. Now we're going to go to the side, and we're going to have to divide these two, right? So we got to move our decimal over. Now I'm going to bring it up. So 13 will go into 83 how many times? What'd y'all get? 6, right? And what's 6 times 13? 78. So what do we get? When we subtract those, we should get 5, right? We bring down the 2. And how many times will 13 go into 52? 4. Evenly? Good. So our answer here would be 6.4 times 10 to the 2nd power, right? Or 6 4/10 times 10 to the 2nd power. Good. All right, we're going to end with this problem right here. Carson, will you read that for me? All right, so let's talk about this one. What does it tell us? It tells us that the population of China was what?
1.3 times 10 to the 9th power.
So I'm going to go ahead and write down here that I know China is 1.3 times, or 1 3/10 times 10 to the 9th, right? Then what's the next thing it tells me? It tells me the United States was what?
387.
Yep, good. So I'm going to write that number down for the United States. All right, now what's it say in the next part of our problem? It says that, what? It asks what? About how many times greater. So let's talk about what that means. What's about tell us to do? Estimate around. Yep. So I'm going to go ahead and estimate the United States number, all right? So if I were to estimate this number, what would I estimate it to? We're estimating it in scientific notation. So if we start back here, we're going to move our decimal how many times until we get a factor between 1 and 9? 8, right? Well, if we were to estimate, is 3.08 going to make that 3 go up to a 4? So I'm just going to get 3 times 10 to the 8th power. Good. So now I have both my numbers expressed in scientific notation. So now let's figure out what it's asking. It's asking how many times greater was the population of China than the United States. What do y'all think operation we're going to have to do? All right, let's talk about it. If I were to ask you how many times greater is 12 than 4, wouldn't we divide because we figure out what? 12 is how many times greater? 3 times greater. Because when we divide, we're figuring out what times 4 gives you 12, right? So also think about, so we figured out how many times greater is asking us to divide, right? Well, when we divide, does order matter? Sarah, does it matter? Yes. It does, right? Not when we're multiplying, but when we're subtracting or dividing, it does, right? So let's talk about what order it's going to be. When I just asked y'all this problem, I said how many times greater is 12 than 4, Christian? What's the order? Yeah, because you weren't paying attention. Gray, help him out. So the order I said was how many times greater is 12 than 4. Do we hear that pattern there? So let's look at our problem. That was an example. It says how many times greater was the population of China than the United States. So what do y'all think the order is going to be? What divided by what? China divided by the United States. Good. So now that I know what those two numbers are, I'm going to plug that in. So I'm going to plug China's number in, and I'm going to divide it by the United States. Okay? All right, so somebody who has a calculator, tell me what 1.3 divided by 3 would be. You got it, Ollie?
Yeah, it'd be 0.4333333.
Okay, so it's repeating, right? So we have we have 4/10, basically. If we rounded, we get 4/10, right? Yes? Because it says about, right? So we're estimating. So if it didn't say to estimate, then we could write it out like that. But since it says to estimate, we're just going to get 4/10, right? Well, when we are dividing, what do we do to our exponents? Subtract. So what do we get? Times 10 to the what? First power. Well, this problem didn't say to leave it in scientific notation. It's saying to figure out how many times greater China is. So let's change this into standard form. So how would I make this into standard form? This positive one tells me to go what? Right. To the right one with my decimal, and what number do I get? 4. So I could say China is what? 4 times greater than the U.S., right? So we're going to leave it like that, and we get that China is 4 times greater. Does everybody see that? All right.